Well, good morning and welcome to our cosmic conversation for this Friday. My name is Ryan White. I'm the Senior Director of Morrison Planetarium and Science Visualization. And during the time that we're closed, we're trying to bring some of the Morrison Planetarium excitement to streaming video. And our Friday program gives us a chance to talk to experts in the different fields. Today, we have Mark Showalter joining us from the SETI Institute. So, hey, Mike, thanks for joining us.
Good to be here.
And Mark was part of the New Horizons team that explored Pluto, and it was just 5 years ago this week that the New Horizons spacecraft sped past Pluto, and I really do mean like sped past Pluto. So we thought we asked Mark to join us to talk a little bit about the mission. So actually, first off, I guess I should ask, does it really seem like 5 years?
No, well, things have been crazy since then, of course, because just a little over a year ago, we did the flyby of a Kuiper belt object. So we've been busy. We've been keeping very busy, but we're still figuring stuff out about the Pluto system based on the data we got 5 years ago.
Absolutely. And so we're actually kind of starting out with a view of not just Pluto, which is sort of at the center of the image here, but also its 5 moons, which is kind of extraordinary. I mean, I think, a lot of us are still getting used to Pluto not being classified as a planet, and then to learn it has 5 moons is pretty wild.
Yeah, that's right. We actually, at the time that the New Horizons spacecraft was launched, we only knew about Pluto and Charon. Pluto is, of course, that dot there in the middle, and Charon is the first little ring around it. My colleague, Hal Weaver, and others using the Hubble telescope discovered Hydra and Nix, 2 smaller moons, shortly after the launch. And then in the subsequent years, in 2011 and 2010, that time frame, I was working with the Hubble telescope and working with the team as well, and we discovered 2 even smaller moons. So that gets you up to the 5 that you can see right there.
That's pretty wild. And so when New Horizons launched, we actually only knew of 2?
We only knew about 2 bodies. We only knew about Pluto the 1 moon,
so
Charon.
Pluto and Charon. Wow.
And yeah, I just want to mention something about just what you're looking at here. So imagine yourself on a spacecraft flying toward this system at 17 kilometers per second, which is pretty darn fast. And at that point, you start to think, well, there's all those little bodies flying around. Maybe there's some dust in the system. And what would happen if our lovely spacecraft that we care so much about were to hit one of those tiny dust grains? It doesn't take much at 17 kilometers a second to essentially blow out a critical component. And then although the spacecraft might keep going on its merry way, it would be dead to us in that we would never get any data back from it. So I was actually very involved in figuring out, like, if we're going to fly through the system, looking ahead and seeing, is there any dust there? What do we do if we see something that might be scary and we have to divert? There was a whole lot of adventure, I'll say, going up to that flyby, just because we really were flying into the unknown.
Right. The most distant object that a spacecraft has ever visited.
That's right.
Yeah. So
a record only met by the Kuiper belt object that we encountered a year ago.
Visited later. Yes. Well, maybe we could zoom in here and take a little bit closer look at Pluto. And I should note that I'm kind of doing some flying here, and so I have control over the cursor. So I'll do my best, Mark, to point out things as you talk about them. But I'll try to use the cursor as something useful. I have to use it to kind of pilot through the system. But here we're seeing a view, kind of what New Horizons would have seen on its approach a few days before it actually encountered Pluto.
Yes, I believe this is the blue view from July 11th, where the flyby was essentially the 14th and then into the 15th. What I want you to appreciate here is that Pluto rotates in about 6.5 days. And as a result, we're now like 3 days out from Pluto. We're looking at the face of Pluto that we are never going to see again with the spacecraft. And I don't know if you can see some kind of weird stuff. There's you can see kind of some craters, and there's some black areas in the bottom. I mean, we knew at this point that we were going to fly by a very interesting object. This is not just a sort of, cratered ball. This is something that has all kinds of dynamic, interesting geology going on, but it's also a bit heartbreaking because we're never going to see this again. We're never going to get a better look at what's going on this face of Pluto.
Right. This is very much a one-shot deal that having traveled this far, it's getting one quick look.
Right.
Well, I could fast forward to the 12th if you want.
Yeah. So day by day, then, as we're approaching the flyby, we're getting a new view. And so it's like this was the 12th then, and now we see that something really interesting is going on, because you can see that big white area off to the left, plus the very dark area to the right. So this was just, once again, telling us more and more about some very interesting physics, very interesting geology that's going on. And then, a day later, as Ryan will show you, this is essentially what we were seeing just as we were getting up and approaching Pluto. And that big white area looks like a heart. I mean, it just looks like a gift to us that, not only does Pluto look amazing and interesting and delightful, but there's a heart there for us. But that is now called Sputnik Planitia. And if you, and you can see then some very dark areas off to the left. What day is this, Ryan? Remind me.
This is actually the 13th. So
yeah, the 13th. So we got one more day to go here.
So this then, we've just fast forwarded basically to the view that New Horizons has on its closest approach.
That's right. And so immediately, there's some very interesting things going on with the very white area and a very dark area. Most planets are just kind of gray. Most celestial bodies are kind of gray. So having this kind of bright and dark tells you that there's some very interesting things going on. You can see some linear features. There are crevices. That big white area, as we got a closer look, doesn't have a single crater on it, which means it's a very, very young surface. Something we really did not expect to see. In the solar system, everywhere you look on any solid body, you find craters. And yet here on this big white area, there's just not a one. So once again, it's a very young surface. There's a lot of material that's probably some kind of ice. It's nitrogen ice and other kinds of ices, of course, water ice as well, mixed together. Then there's mountains off to the lower left, big dark areas where dirt, that's a technical term, carbon compounds are being deposited, making other areas very dark. It's just such a delightful world, something way beyond what you might have expected, particularly when you think how far we are from the sun. There's not really much of a heat source. So the idea that there's active geology in a body that's been out in the frozen distance of our solar system for billions of years was really quite a surprise. And we continue to learn more about these craters and linear features and all the active things that are happening on this distant world.
And it's so cold out here that basically water ice is as hard as rock. And then this frozen nitrogen, oops, sorry, that's my bad piloting there, off to the right that forms Sputnik Planitia. That's kind of I know Alan Stern, the PI for the New Horizons mission, referred to it kind of as a consistency of toothpaste.
Yeah, that's right. So we actually, in other images, we see glaciers, which are this toothpaste stuff flowing downhill. The mountains are essentially, I think of these mountains as ice cubes. In this cold environment, having a mountain that tall, you know immediately that it's made of ice, because all of the other ices that make up the surface of Pluto are not strong enough. If you tried to build a mountain out of the nitrogen or something else, it would flop down again. So one reason we know that these are ice mountains that we're seeing here is that they are too tall to be made of anything else.
It's still pretty wild to think of nitrogen, which of course is something that we inhale every moment, is basically a solid, a messy solid out here at Pluto.
That's right. That's right. And I like the fact that you've backed up there a little bit, Ryan. So there off to the left, you can see Charon. Charon is the large moon, the largest moon, the only one we knew about, of course, at the time of the launch. It is almost half the size of Pluto itself. So it's an interesting world in and of itself. In fact, Pluto and Charon are something we sometimes refer to as a double planet. The idea is it's not really that Charon is orbiting Pluto, it's that Pluto and Charon are orbiting around their kind of center of mass. It's as if there was a big, there are two ends of a lopsided dumbbell rotating together. And so here we're seeing the close-up of Charon. And now in the reality, just as we were getting that last image of Pluto, the spacecraft went silent and we had to wait, make sure, just wait and wait, because the spacecraft was then executing all of its close-up observations of both Pluto and Charon. And then a bit later, we finally found out whether everything had worked okay or not. It was a very harrowing bit of time for us on the team. But there you can see that even Charon itself is a very interesting body. You can see maybe off to the right, it's a fairly smooth terrain, whereas then off to the left, there are more craters. Essentially, Charon seems to be like it's it's two bodies stuck together almost. It's essentially, we believe, it's kind of been fractured, and that big linear is kind of off to the sort of 130 down to 730 angle, 45-degree angle there, is kind of a dividing line, because this body, as it freezes, the whole crust is kind of broken apart and has created that great big linear feature.
That's wild. And I should note here, just to be clear, what we're looking at is actually what we've done is we've taken the images from New Horizons and we've mapped them onto the surfaces of our it's kind of a virtual model of Pluto and Charon that we've been looking at. But having said that, actually, and since we're talking about New Horizons, let me go ahead and just take us to actually see the spacecraft. And I'm actually going to take us there, dip down to black and go back, just as it has kind of bypassed Pluto and Charon. Well, someone actually is asking what else New Horizons has explored after passing Pluto, and I think we'll get to that in a moment. But maybe we can talk a little bit about this kind of blue haze that we're illustrating over around Pluto. And actually, I'll go ahead and speed up time as if we're
yeah. But notice that beautiful blue haze there. Pluto. We actually knew Pluto had an atmosphere. That was discovered by some wonderful scientists, James Elliott at MIT and his team members back. I'm afraid I'm not going to quite get the year right. I think in the 80s. And that was based on the fact that there are certain compounds that just wouldn't be there if not for the fact that it was all in a gaseous phase. That's another very strange thing about Pluto. As a very cold body, how is it that it has an atmosphere? In cold temperatures, almost anything condenses out onto the surface. And that seems to be, once again, related to this idea that these ices in the sunlight, there's not a lot of material, but some of it gets lifted off the surface. And when it does, it hangs around for a while before it lands back down. And so this is a beautiful kind of a haze that you can see now as we're looking back at Pluto from the far side. You know, we normally see Pluto on the other side, but here the spacecraft is looking back at Pluto, and that haze is kind of glowing in the sunlight. Quite a great, beautiful result, and a very interesting one.
And New Horizons actually set aside time to make sure that there would be the opportunity to observe the atmosphere, basically looking at the sunlight through Pluto's atmosphere, right?
Yeah. In fact, not only did we do that, but we had an opportunity to send radio waves from the spacecraft through the atmosphere and to Earth. And so we actually have some radio data that tells us things about the density of the material in a sort of a linear cut through the atmosphere, which is very interesting results too.
And we're sort of too far away to say it, but the atmosphere also has sort of multiple layers in it, so it's a really complex sort of structures, which is
right. It's Pluto. We would not have guessed if we just heard about Pluto today. We would never have guessed that this is a body that has an atmosphere, and yet there it is.
Well, and actually, then, since we did get a question about what else New Horizons has explored, maybe that's a good cue to take a look at its second destination, which is I
want to mention. I mentioned since someone asked. So the what else? There's an additional answer to the what else, which is that New Horizons did a flyby of Jupiter. That was basically just a year after launch. We did a whole lot of work. That was a great opportunity. I mean, we've been to Jupiter before, but the idea that we could see it up close and test out all our instruments and calibrate all our instruments, it was a great opportunity. But then the whole mission, as it was originally envisioned, was going to be a flyby of Pluto and then some Kuiper belt object. If you recall, the Kuiper belt is a collection of tens of thousands or more bodies way out beyond Neptune and Pluto in the solar system. Very primordial, very old bodies. They've essentially been in deep freeze since the solar system formed 4.5 billion years ago. And we had to do a lot of work as a team to find the next target after the Pluto flyby. We had guessed at the time of the launch that at the rate people were finding Kuiper belt objects, there would surely be one on our path, because we could tweak it just a little bit as we did the Pluto flyby. But we were very, very lucky to find and advance this object now called Arrokoth. And so this was nothing but a dot in the sky of the Hubble telescope. We really had never seen it even from an Earth-based telescope, as far as I know, prior to the arrival. But then we did this flyby going, now this was into December 2018 into January 2019. And here we are seeing an object. Now this is a model. I think we may be able to cut forward to the
sure, I can also show the actual.
Let's just say a couple of obvious things about it. This is two objects stuck together. It's called a contact binary. It's had been some evidence prior to this that many of the Kuiper belt objects that we see formed somehow as two objects going around each other and then eventually kind of got stuck. And this is like if we had ever wanted to know what does a contact binary really look like, because it was just a hint in our data. Having this image then come down to Earth and let us all look at it is just kind of such a remarkable thing. These are very, very primordial objects. They probably formed in the first tens of millions of years of the solar system, and they got stuck together, possibly because there were other bodies around and they were all swirling, and two stuck together and the others escaped. We don't really know. But here they are. You can see there's essentially one big crater there that you can see at upper right, and then a few little ones, but not really many craters. That's interesting because it says that there's just not a lot of stuff out in the Kuiper belt, whereas in the inner solar system, you see cratered balls everywhere. Here you see an object that really hasn't had much of anything happen to it in the last 4.5 billion years.
And so this is really helping us tell us about the early history of the solar system as well, being able to look at this.
Yeah, so essentially so this is a cold classical Kuiper belt object, which is another way of saying that it's been there forever. It's formed there and it has really not been modified in any significant way. There are other classes of Kuiper belt objects. There's bodies that have been tossed out there and tossed around a bit. But this is kind of one of the oldest and most primordial primitive objects. It is the most primitive object we've ever seen. We've never been able to see in any way an object that hasn't been modified by being in the solar system for 4.5 billion years. But this one has essentially been in deep freeze for all that time.
And then what we're showing here, as you mentioned earlier, is actually a three-dimensional model that's based on multiple observations. So taking pictures of this as New Horizons flew by, it turns out that one of the two members of the contact binary is actually kind of a flat, more disc-shaped.
Yeah, in fact, they're both. There's been a lot of modeling done to figure out the shape of this object. It's tricky. Obviously, you can see it's a tricky thing to figure out its shape. We actually didn't see the dark side of Arrokoth, which your animators can do a beautiful job of showing us, but there's no light out there, obviously. And so the reason we know it's flattened is not because we saw the other side, but because we saw it silhouetted against star fields, and we know where the stars weren't visible. And essentially that tells you that these were both actually somewhat flattened objects. The larger one is a bit more flattened than the small one, but they're both flattened. And that once again tells you that these were objects that there was probably a swarm of objects and they were spinning around, because that's what you need to do to get things to flatten down like that. And then as time went on, they deformed and solidified flat, and then their orbital mechanics led two of them to merge. And if there were other bodies around, they've left the system.
Very cool. Yeah, so it's a great point that we do some things for the comprehensibility of the visualization that can be a little deceptive.
Yeah, well, I wish we could have had a big flashlight. Yeah, look at the other side.
Flashlight. Well, so I think that's a good sort of summary of the New Horizons mission. And what do you think the potential is for any future missions to this part of the solar system?
Well, I mean, there's two parts of that question. We are still looking for another target. It's because we're already well out into the Kuiper belt. There's not great chances that we would find something that is on our path in a way that we would actually be able to do another flyby. But we're going to try. NASA wants us to try, and we're throwing every resource we can at that problem. So far, we don't see any great opportunities. What we are doing, though, however, is that even though we're not going to be close to any other Kuiper belt objects, we are out there in the Kuiper belt. And that means that we can do things like look at the backsides and the side views of many Kuiper belt objects that are around us. They're all pretty far away, but we can still look at them. So we're learning things about the Kuiper belt just by being out there that we could not do from Earth. And that's very important science. NASA is currently in the process of thinking about next decades of research projects. And so there's definitely a lot of interest in revisiting the Kuiper Belt, finding other ways to do it. The trouble with the Kuiper Belt is that it's far away and there are a lot of bodies out there. So the best way to study the Kuiper Belt is mostly from Earth. And we do have an opportunity coming up. It's called the Vera C. Rubin Observatory, which will be essentially surveying the sky from Chile for 10 years or so. It will be detecting, whereas right now we know, tens of thousands of Kuiper Belt objects, it will be detecting essentially everything down to a much smaller size in the Kuiper Belt. So learning about the Kuiper Belt is something we'll probably be doing from the Earth from the time being, but we have a huge body of data that's going to be coming to us and be available to us over the next decade or two.
Well, I did, since we were talking about the Kuiper Belt, I kind of added this. These are some of our known Kuiper Belt objects. Pluto's orbit and Arcos orbit are kind of highlighted here, but there are thousands of these objects that we now know of. And
right,
and finding more all the time.
Surely there are millions that we will know about eventually.
Right.
And somewhat tangentially related, I wanted to pop in for a second because I've got an eye on the SETI Facebook stream as well, and there are a couple of questions that were coming in on there. And someone was wondering how long it'll be before New Horizons hits the heliosphere and the heliopause.
That's a really interesting question. So the helio, just to make sure we're all on the same page, so the sun's influence only extends out so far. At a certain point, the solar wind sort of loses out to the surrounding galactic environment. And the Voyager spacecraft, only in the last number of years, have crossed the heliopause, where they really no longer detect the pressure from the sun. They are mainly in interstellar space now. Unfortunately, it will get there eventually, but unfortunately for us, because Voyagers did multiple planet flybys, they are actually moving faster than New Horizons ever will. New Horizons will continue to go out of the solar system at its current speed. It will, I don't know the estimate exactly, but it will be of order decades before we actually get to the heliopause. But meanwhile, there's a whole lot of science we're going to be doing with the spacecraft just because we have this platform that is so far from the sun and can look at things in ways that we cannot.
Well, actually, New Horizons also has a pretty spiffy telescope, right? For compared to most spacecraft that like Voyager and
I won't say it's better than Voyager because we have decades of better technology. It's a very powerful telescope. Let's just leave it at that. It's not as powerful as something. I mean, it is a 1 megapixel camera. If you think about that, that doesn't sound so impressive. Yeah. Camera is 48 megapixels that I carry around. My phone is 10 megapixels or something. But it is a very sophisticated camera, very, very capable of studying the skies. And because we are so far from Earth, they've done a new set of experiments where, just to get people involved, we can now look at common star fields and see that some of those stars are shifted relative to others because the foreground stars with parallax, because we're so far away, we get a parallax effect. And so there's been a project where we're looking at certain star fields with the camera, and then we are also encouraging Earth-based observers to look at those same star fields, and they will be able to see that our image shows one star a little bit shifted relative to all the others. Calling it alien skies, which I think is a wonderful name for it.
That's very cool. Yeah, I didn't realize that was a citizen science project, because what we're showing here then is the trajectory of the New Horizons spacecraft out from Earth to now just beyond Arcos, and you can see that if you think of Earth as one end of the baseline and New Horizons is another, it's a much longer baseline than we've ever had before.
That's right.
For making parallax observations.
Right.
Very cool. Well, Mary, were there other questions from SETI?
Let me see. Oh, someone early on asked where Planet Z is.
Planet Z.
That's a very interesting question. So I think maybe the question is about something that's called Planet X. I don't know. I lose track of these designations. Right. But there's been a proposal that there's a very, very large object out in the very distant Kuiper Belt that is capable of inserting a certain amount of order. There are certain aspects of the orbits of all the Kuiper Belt objects that suggest that there's something going on to kind of organize them a little bit. And one model for that is this concept. I've heard it called Planet X. I've probably been called Planet Z as well. I'll say I'm a skeptic of this particular theory. We've studied the Kuiper belt so thoroughly that it's becoming hard to believe that there's a very large object, and I think they're talking about something like Neptune-sized, that there's a very large object out there that somehow we have overlooked all these years. And it may well be that there's just some other dynamics going on that imposes the order that we see in the Kuiper belt. But if there is a planet X, it has to be kind of on the other side of the solar system. For a variety of reasons having to do with if it were anywhere else, it would have been seen by now. And there's this narrowing bit of space where if it's there, we would not have seen it yet.
Right. We actually do have a data from simulations that to illustrate that. And unfortunately, I don't have it preloaded in the system. Otherwise, we could go down that rabbit hole pretty deeply. But yeah, it's an interesting question. But yeah, a lot of the jury is definitely out on that one.
Another one that's relevant to New Horizons too. Someone asked, could we turn the telescope towards Earth and get another pale blue dot picture?
Yes, and I think there is actually some thought about that. It's we want to be far enough away. Remember, these cameras, they're very sensitive, and so you could actually. So it was a very, very strict rule in the management of the camera that it can never look toward the sun because the sun is way too bright, and you don't want to burn out the optics. Or damage them in any way. So as we get further out, it's going to become safer to look at the sun. So there is a thought about doing that. The best camera, the most powerful camera on the spacecraft is monochromatic. It has no color filters. It is just black and white. And so in that camera, it wouldn't be a pale blue dot. It would be a pale gray dot, I'm sorry to say. Yeah. But we do have a different camera. It's not quite as powerful in the way it resolves, but it does have some color filters, so we could get that color image that way. And there's definitely thought about doing that. I think we're still actually too close to the sun for people to feel comfortable turning the camera and pointing it in that direction. But as time goes on, that will become possible.
Well, because New Horizons was really designed for doing its work in the outer solar system, right? Where it isn't much light. So of course it was, you'd want a very light sensitive camera to put out that far away from the sun. So yeah,
that's right.
It would be scary to turn it back and look at the sun.
Right.
Looks like we just got one from the YouTube page as well. Can we lodge the craft in an extrasolar, extra Kuiper equivalent of a Lagrange point to be used as a relay for a deep space network?
Oh, that sounds like such an interesting idea that we can't do, I'm sorry to say. At this point, this spacecraft was launched fast. I mean, I was actually at the launch. It just left Florida and kept going as it crossed the orbit of the moon in 9 hours, I think. You can't slow it down. You can't stop it. You can tweak its path just a little bit based on these propellant, these little jets that we have on there. But so there is nothing we can do to slow it down that would enable it to get into any kind of a specialized orbit like that. I'm sorry to say. Would have been an interesting idea. I've got to admit, that's great.
Definitely a moving target.
Yes.
All right. Well, if that's our questions for the session, then I think thank you very much for taking some time to talk to our audiences about New Horizons, celebrating its 5th anniversary of encountering Pluto and long and continued potential for exploring more Kuiper belt objects, although maybe not in as great up close detail.
Right, but we can hope. But thank you, Ryan. It's been great. I've enjoyed speaking to you.
Great. Thanks.
And I wanted to suggest a shameless plug for our Morrison Facebook page as well, Ryan.
That's a great point. Since some of you might be watching this on the SETI Institute page on YouTube, feel free to take a look at Morrison Planetarium at the California Academy of Sciences on Facebook, and you can see more programs like this. Not only talking to experts, but also kid-friendly programs, open-ended exploration of the solar system on Wednesdays, and all kinds of other night sky stuff. So thanks for joining us for our cosmic conversation, and we'll look forward to seeing you virtually and maybe someday soon back in the actual Morrison Planetarium. Thank you.
Thank you.